11.2 solutions by using the quadratic formula. Okay, so first off, I guess I'll start with solving linear equations. So suppose I have the equation x plus a equals 0, and this is for a being a natural number. Well, then it turns out that if I subtract a from both sides, well, actually, let's do it this way. Let x equals z minus a. Then replace x by z minus a, plus a is 0, and so the a's cancel. So you get z equals 0. But since z is 0, then I have that x is equal to 0 minus a, and so x is equal to a. Which means that we would have to introduce, well, even if I start out with a natural number, uh, then to solve this equation, I'd have to extend my field of possible solutions to the integers. And so I'd have to extend the solution set to the set of all integers. And so we have to actually expand the set of all possible solutions to include those that involve, well, integers. In matter of fact, if I look at equations of this type, again, linear equations, where both a and b are natural numbers, then let x equals z minus b over a. Well, then we have the following. A, and of course, well, I'm assuming a is not 0 since a is an integer. Then I have ax plus b is 0. And so let's multiply a inside the parentheses. So I get that az minus, well, the a's cancel, b plus b is 0. The b's cancel. So I get az is 0. But since n is a natural number, then that says that z must be 0. And so plugging in 0, I get that x is equal to a negative b over a. And so in this case, again, we have to extend the solution set, the set of all possible solutions, to, well, um, the rational field. And so I have to be able to include fractions. And so notice that we had to basically, even if we're starting with this nice linear equation, and each of these coefficients here, A and B, are natural numbers, in order to get solutions to this, I'm going to have to also be able to allow um, rational solutions. And so if I do that, then I'll be able to determine every possible solution. And so that's basically a technique to solve linear equations. Let's try quadratic equations. So let's say something in the form ax squared plus bx plus c is 0, where a, b, and c are, let's say, natural numbers. Let's see what happens, even in this case. And so, again, well, let's do the same thing that I've done up here. I'll let x equals z minus b over 2a. So now that we're doing quadratics, rather than just b over a, I'll do b over 2a. And so I get ax squared plus bx plus c is 0. And so I get a, and so let's square what's inside the parentheses. So z squared minus b over az plus b squared over 4a squared plus, well, let's multiply b inside the parentheses. And so I get bz minus b squared over 2a plus c is 0. Let's multiply a inside the parentheses. And so I get here az squared minus bz plus b squared over 4a plus bz minus b squared over 2a plus c is 0. Well, bz's cancel. Let's multiply both sides of my equation by 4a. And so you get 4a squared z squared plus b squared minus 4a divided by 2a is 2, b squared plus 4ac equals 0. And so I can combine like terms, so I get 4a squared z squared minus b squared plus 4ac is 0. Add b squared to both sides of your equation. Subtract 4ac from both sides of my equation. And so I get 4a squared z squared is equal to b squared minus 4ac. And so, since a is assumed to be non-zero, then I can divide both sides of my equation by 4a squared. And so I get z squared equals b squared minus 4ac all over 4a squared. And so by the square root property, I get that z equals plus or minus the square root of b squared minus 4ac over 4a squared. Well, I can take the square root of the numerator and the denominator and use the fact that 4a squared is just 4a. So z is equal to plus or minus the square root of b squared minus 4ac all over 2a. Well, I can get rid of the absolute value, but if I do that, then I'm going to either multiply by a positive or negative. Well, I already have a plus or minus, so it's still plus or minus. And so now let's plug z back in. And so I get that x equals negative b over a plus or minus square root of b squared minus 4ac all over 2a. And so I get that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we call this the quadratic formula. Okay. Let's do this technique. Well, the same. Let's rederive the quadratic formula, but I guess I'll do it using completing the square. So we can see that we can also derive this formula by the technique of completing the square. And so I have ax squared plus bx plus c is 0. So let's subtract c from both sides of my equation in order to isolate the x's on one side of my equation. And so I get ax squared plus bx equal negative c. And so now what I'll do is I'll add and subtract the following to both sides of my equation. And so I take b divided by 2a, so b over 2a, square that, and then multiply by a, and add that to both sides of my equation. And so that's going to be a b squared over 4a minus c. And so I get a times x plus b over 2a squared is equal to, well, let's get a common denominator, 4a. And so you get b squared minus 4ac all over 4a. Divide both sides of your equation by a, same as multiplying by 1 over a, the reciprocal. Multiplication, division is the same as multiplication by the reciprocal. And so you get x plus b over 2a squared is equal to b squared minus 4ac all over 4a squared. Therefore, by the square root property, x plus b over 2a is equal to the square root of b squared minus 4ac all over the square root of 4a squared is 2a. And so now I will solve this equation for x. So subtract b over 2a from both sides of my equation. And so you get that x is equal to a negative b plus or minus the square root of b squared minus 4ac all over 2a. And so we get the same quadratic formula that we derived before. And so let me also extend this idea to, let's say cubics. And so let me actually box this for you. Actually, first, let me tell you about the discriminant. And so let me give you some notation, I guess, first. So let d equal b squared minus 4ac. And so that's your discriminant. Your discriminant is, in this case, just what's inside the square root. So that says that actually you can determine the nature of your roots just by looking at the sign of the discriminant. And so let's do that. Nature of roots. So this is for quadratic, for quadratics. So if the discriminant is 0, that means that you're adding and subtracting the square root of 0. Well, the square root of 0 is 0, and therefore we have a single double root. So I have that my two roots are actually the same root, and so I have a double root. Well, I'll say two equal roots. And so that is called a double root. And it turns out that if, in addition to the discriminant being 0, if b over a is a rational number, then you'll have a rational double root. Double rational root. Suppose that your discriminant, so that's more or less case 1. If the discriminant is less than 0, then you're adding and subtracting square roots of negative numbers. And so that says that you'll have two distinct complex roots. And so, um, basically, in any case, you're going to be having a some sort of complex root. And since you're adding subtracting something that's not zero, you'll actually have two complex roots. And it turns out that they'll be um, complex conjugates of each other. Okay. Third case is the discriminant is greater than zero. So you're adding and subtracting the square root of something that's positive, and so you'll get two distinct real roots. Suppose, in addition, that the discriminant is greater than zero, and that let's say that D is a perfect square, and that basically B over A is rational. Well, I'll just assume that A, B, and C are natural numbers. Okay. Then, since I'm taking the square root of a perfect square, then it will be some sort of natural number. And so I get that I'll have two distinct rational roots. Okay. And well, they'll be conjugates of each other. So you have a conjugate pair of roots. Next, suppose that the discriminant is greater than zero and that A, B, and C are natural numbers. And that D is not a perfect square. Then in this case, um, we're going to have, oh, I didn't need that. I'll have, um, well, since A, B, and C are natural numbers, uh, then I'm adding subtracting the square root of a perfect square, so I'm adding subtracting some uh, natural number, or whole number at least. Then I'm adding, subtracting the square root of something that's not a perfect square, so I'm adding, subtracting uh, some sort of uh, irrational number. And so I have that, hmm, there. Okay, why is this not working? Okay, 1 second. Okay. Hmm. Okay, let's try that for a second. Okay. And now let's come back to this. Okay. Let's try. Okay, why is it not? Why am I not able to select? Huh. Okay, let's try this then. Huh. Okay. This is. Oh, I think I'm frozen. Oh, wait. Almost. Oh, well, this is interesting. Why can't? Okay, let me close this at least. Huh. Ah, okay. Ah, there. Okay. Let's see if this will alleviate the problem I'm having with selecting my pen to write with. Okay. It's working now. Okay, good. So if it's not a perfect square, then and A, B, and C are natural numbers and the square is greater than 0, then you'll have two distinct irrational roots. And that's an error there. Irrational roots. And they come in conjugates. They'll be conjugates of each other. So these will be conjugate pairs. Okay, good. I finally got through with that. Um, so that tells me how I can classify these um, roots of quadratics. So finally, uh, maybe I'll give you a quick little blurb on solving higher order equations. Well, no, I guess I won't. Let me just do some examples on page 468. Let me do problem number 2. 6x squared minus 3 equals negative 7x. In exercises 1 through 10, write the equation in the form ax squared plus bx plus c, and then identify a, b, and c. Okay, so let's do that. So first thing to do is to add 7x to both sides of your equation. And so you get 6x squared plus 7x minus 3 is 0. And so that says that in this case, a is 6, b is 7, c is negative 3. Let me do problem number 9. 6 plus x, 10x, 10 plus 2x, minus 60 equals 36. So let me multiply this out. So you get 60 plus 12x plus 10x plus 2x squared minus 60 equals 36. The 60s cancel. Let's combine like terms, and let's write this in descending order. 2x squared plus 22x equals 36. Subtract 36 from both sides of my equation. And so 2x squared plus 22x minus 36 is 0. Let me divide everything by 2. That will make plugging into the quadratic formula much nicer. So you get x squared plus 11x minus 18 is 0. And so in this case, a is 1, b is 11, c is negative 18. Okay, let me do problem number 14. Let's try that again. Problem number 14. X squared minus 5x plus 3 is 0. And so in exercises 11 through 50, use a quadratic formula to solve the equation. Okay, so let's do that. And so let me write down the quadratic formula first. So I have here that x is equal to negative b plus or minus the square root. I have to move this down. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And so I have here that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so I get that x is equal to 5 plus or minus the square root of negative 5 squared is 25. 4 times 1 times 3 is 12. 2 times 1 is 2. 25 minus 12 is 13. So x is equal to 5 plus or minus the square root of 13 over 2. And that is your answer. Let me do problem number 34. Five r squared equals 3r minus 2. Subtract 3r. Add 2 to both sides of your equation. And so I have here 5r squared minus 3r plus 2 is 0. And so let me use the quadratic formula. R equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So r is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so r is equal to 3 plus or minus the square root of 9 minus 40 over 10. And so you get here 3 plus or minus the square root of 9 minus 40, negative 31 over 10. And so the square root of a negative number, we'll just introduce I. And so I get 3 plus or minus I radical 31 over 10. Let me do problem number 50. So you must be aware that if you have a formula that you're using, then you have to be sure that the form from which the formula was derived has to be identical to that original form. And so let me do problem number 50. Y minus 2, y plus 2, minus 3y, y plus 1 equals 5. Okay, so let's simplify this. So this is the product of the sum and difference of two terms. So that's just the difference of their squares. Y squared minus 4. Let's multiply negative 3y inside the parentheses. So negative 3y squared minus 3y plus 5. And so combine like terms. 1y squared minus 3y squared is a negative 2y squared minus 3y minus 4 equals 5. Subtract 5 from both sides of your equation. And so I get negative 2y squared minus 3y minus 9 is 0. I would multiply both sides of my equation by negative 1 to get rid of the negative in front of the square term. And so I finally get 2y squared plus 3y plus 9 is 0. So now I can use the quadratic formula to solve for this. And so I have that y is equal to a negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so I have that y is equal to negative 3 plus or minus the square root of 9 minus 4 times 2 times 9. And so that's 72. 9 minus 72. Negative 63 over 4. Let me rewrite negative 63 as negative 9 times 7. And so y is equal to negative 3 plus or minus square root of negative 9 is 3i rad 7 over 2. Okay, let me do problem number 50. 2x squared minus 2x minus 40 is 0. In exercises 51 through 58, compute the discriminant of the quadratic equation, determine the nature of the roots of the equation. So first off, before I even plug in, let me divide by 2. That will simplify the computations. And so I get x squared minus x minus 20 is 0. And so let me plug into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And so x is equal to negative b, the opposite of negative 1 is positive 1, plus or minus the square root of b, negative 1 squared, plus 4a, negative 20. All over 2 times, well, a, which is 1. And so you get that x is equal to 1 plus or minus the square root of 1 minus 80, negative 79, 2. And so you get x is equal to 1 plus or minus I rad 79 over 2. And that is your solution. Okay. Let me do problem number. Wait, I wasn't doing 50. I was doing 52, which is to compute the discriminant. And so let's compute the discriminant. Okay. So the discriminant is just equal to b squared minus 4ac. So b squared minus 4ac. So d is equal to 1 plus 80, which is 81. That's a perfect square. And so this says that, well, I have 2 distinct real roots. Well, rational roots. Oops. Okay, so let me quit this. Let's see if I can select this. There it is.